We're going to begin this lesson talking about the properties of equality. We're going to review the reflexive property, the symmetric property, transitive property, and substitution property. The first property we're going to look at is the reflexive property. The reflexive property states that any quantity is equal to itself. For any number A equals A. So we know that 5 equals 5, or if we have 4 plus 7, that's going to equal 7 plus 4. One way to remember this property is reflexive sounds a lot like reflect or reflection. So what is on one side of the equal sign is the same as what is on the other side of the equal sign. It is a reflection. The next property we're going to take a look at is the symmetric property. If one quantity equals a second quantity, then the second quantity equals the first. So what they mean is that if you have any numbers A and B, if A equals B, then B equals A. So if you look at an example and we say that 3 plus 6 equals 9, then that would mean that 9 equals 3 plus 6. So no matter which way you're looking at it, it's symmetric. It's symmetrical. So you can flip the problem and it still equals itself. This next property is the transitive property. If one quantity equals a second quantity, and the second quantity equals the third quantity, then the first quantity equals the third quantity. This can be a little bit of a mouthful and can be a little bit confusing, but I'll show you an example, and then as you continue to work through some of the practice problems on your own, I think you're going to be able to grasp this and kind of get a better feel for the property. So it says for any numbers A, B, and C, if A equals B and B equals C, then A equals C. So let's take a look at an example. 6 plus 9 equals 3 plus 12. Well, if we know that 3 plus 12 equals 15, so this side of the equation equals 15, then we know that 6 plus 9 have to equal 15, because whatever is on one side has to be on the other. So your problem has to finish out with 15 equals 15. The last property that we're going to talk about for properties of inequalities is the substitution property. And this property reads that a quantity may be substituted for its equal in any expression. So if A equals B, then A may be replaced for B in any expression. When we're using the substitution property, typically you will be given what the value of the variable is. So in my example, we're going to say that n equals 11. So for that, anytime that you would see n in any expression, then you would be able to substitute 11 for n. So if we had the expression for n, then we would write that as 4 times 11, which would end up with a result of 44. The next set of properties that we're going to look at is the addition properties, and there's two of them. The first one is the additive identity, and that is when for any number A, the sum of A and 0 is A. The second one is additive inverse, and this is a number and its opposite are additive inverses of each other. And we're going to take a look at both of these properties separately in future slides. We're first going to talk about the additive identity. And remember that the definition for additive identity was for any number A, the sum of A and 0 is A. So A plus 0 equals 0 plus A. So if we take a look at an example, 2 plus 0 equals 2, or 0 plus 2 equals 2. So if we were using the 2 as the replacement for the variable, we can see that 2 plus 0 equals the 2, and the 0 plus 2 equals the 2 again. The additive inverse, and we reflect back to the definition, and the definition was a number and its opposite are additive inverses of each other. So positive a plus a negative a equals 0. So I think the easiest way to look at this one is to look at a number line. So if we have our number line and we have our 0, if we have a positive 3, so 1, 2, 3 is here. Now if we add a negative 3, so if our problem was like this, 3 plus negative 3, we have our positive 3. Now to go negative 3, we go 1, 2, negative 3, that ends us at 0. So anytime that you add a number and its opposite, you're going to end up at 0. And to remember that, you can picture the number line. If you start at 0 and you add until you move one direction, and then you add the opposite, it's going to take you back the other direction, ending you at 0. Now we're going to take a look at some multiplication properties. Those properties include the multiplicative identity, multiplicative property of 0, and multiplicative inverse. Just based on the names, you're probably able to figure out what the multiplicative identity and the multiplicative inverse look like, because we just did addition identity and addition inverse. For the multiplicative property, it reads that for any number a, the product of a and 1 is a. The difference between multiplicative identity and additive identity, there are two things. One, with multiplicative, it's a product because we're multiplying, and instead of it being 0, like with the additive property, it is 1. We already know this, but we probably didn't know that it actually had a name. So if we look at an example, 14 times 1 is 14. 62 times 1 equals 62. We know that any number times 1 is that number. The multiplicative property of 0 reads, for any number a, the product of a and 0 is 0. So here we are seeing that 0 come back up, just like we did in the additive identity, although when it's multiplication, it's called the multiplicative property of 0. And we already know this property, we just probably did not know its exact name. So when we're looking at an example, if we have 9 times 0, we know that the answer is 0. We've been taught that any number times 0 is 0. The multiplicative inverse can be a little bit of a mouthful and a little bit overwhelming, so I'll make sure that I show you an example afterwards, and you should be able to get some practice throughout the practice problems. If you need more help with this inverse, please come to me and ask for help. So, the multiplicative inverse, it reads, for every number a over b, where a and b are not equal to 0, there is exactly one number, b over a, such that the product of a over b and b over a is 1. So, if we were writing that out in variable form, that would be written out as a over b times b over a equals 1, or that can be flipped. Let's write it in numerical form. Let's say that a equals 4 and b equals 5. So that means that we would multiply that times 5 over 4. Well, we know that when we're doing multiplication of fractions, we're going to just multiply straight across, and so we're going to get 20 over 20. And any time that we have a fraction where the numerator and the denominator are equal, that equals 1. Let's take a look at this example. This example has a lot of steps, and so I'm going to be using some abbreviation and be writing as small as I can so that I can show you everything that I'm doing. So let's look at the problem. It says 1/4 times 12 minus 8 plus 3 times 15 divided by 5 minus 2. So we first want to start out looking at our parentheses, and we're going to start out with the 12 minus 8. So we want to leave our 1/4. 12 minus 8 is 4, but the directions say that they want us to tell what property we used for each step. So in this example, we used substitution. So I'm just going to abbreviate sub. And we use substitution because we did 12 minus 8 and we substituted the answer for that problem. The next step is to now use substitution again in the other set of brackets. So we're actually going to substitute, in this case, we are going to substitute for the 15 divided by 5. So the rest of the problem stays the same. So we have 1/4 times 4 plus 3. Now we open parentheses. 15 divided by 5 leaves us with 3 minus 2. And again, that was substitution. The next step is to substitute again for inside the parentheses. We're going to substitute right here. So we're going to rewrite the problem. 1/4 times 4 plus 3 times 3 minus 2 is 1. And again, that was substitution. Now we move on to a different type of property. And we have 1/4 times 4 plus 3 times 1. So we can first start out with the 3 times 1. I'm going to make a line here to kind of divide so you can continue following what I'm doing, and I'm going to move up to the right-hand side. So we have 1/4 times 4 plus 3 times 1 is 3. Now, we know that 3 times 1 is 3, and any number times 1 is that number, and that property is the multiplicative property identity. So we can just abbreviate with multi-identity. Now we continue on, and we have 1/4 times 4, which is 1. So that leaves us with 1 plus 3. This example here, or this property, was the multiplicative inverse because we were multiplying two opposites together to get us the 1. And now we have 1 plus 3, which gives us our final answer of 4. And this last step was a property, it was the substitution property. So when you're going through doing problems like this, every step all along the way has a property. You just have to identify what that property is and how you're doing it. And I'm okay if you abbreviate. I do want you to show me every single step along the way to make sure that I understand that you see the change and you see how the problem is slowly getting smaller until you get your final answer.